All right. Hello, everybody. Well, in keeping with the theme of another technical talk, I thought I would tell you all a little bit about bridging because it is very popular, as you can tell. The last talk from the gentleman from Teller, as well as the previous one on Rally, have both covered bridging, and so thought we would double click a little bit more on that. So, everybody's been talking about the multi-chain future. There's been a proliferation of other L1s like Avalanche, Solana, Polygon that are doing quite well in the market right now. They're getting a lot of liquidity, developer activity, but I really think the multi-chain future is the multi-chain present right now. This is a diagram from Dimitri from 1KX put it together in this really good article that he wrote around bridging and the different kind of categories of bridges there are. But I put this up here just to kind of show you the proliferation. Like you can just see how much there is going on, indicating to this very great need for people to be able to send assets and have chains communicate between each other. And when you're thinking about this and trying to contextualize what this means in the greater crypto Web3 industry, one thing to reflect on is how infrastructure and applications do this Texas two step of development between each other. Um, I called this slide Echoes of 2017 because if y'all think back to 5 years ago, that was when a bunch of new modern L1s were founded and funded as well. There was this theme of Ethereum killer where there would be one chain to rule them all that would now be able to scale unlike all the other ones. But turns out that's not what happened. We got a proliferation of L1s that are all kind of working together at this point to enable people to just consume block space. Turns out there's more demand for block space than we anticipated, and we need more than one chain. And I'm seeing Lee from Harmony here. A shout out to Harmony as one of those many chains that have kind of grown and been successful in this market. Um, but I put this kind of diagram up because it shows how this infrastructure app cycle is not something that is unique to crypto. This is a pattern that we see in technology in general, where when you have a free market and when you have technology that allows people to build on it, that infrastructure serves as a substrate upon which people build whatever applications they can. When you at the very beginning, when you have Ethernet, TCP/IP, and kind of rudimentary communications protocols, you start out with things like Prodigy and AOL that test the limits of what that infrastructure can do. Similarly, what that then does is once those applications push the infrastructure to the limit, a new wave of infrastructure happens that then brings forth another set of apps. And so this dance continues and pulls forward both the infrastructure and the applications in the space. In that vein, all of the successful L1s have pulled forth the need to have these bridges because now we have all these DeFi applications, NFT applications, DAOs that are deployed on all of these chains, but are experiencing fragmented liquidity and fragmented applications that developers can't easily connect with each other. And now it's come time for a new wave of infra that will allow them all to connect and form what Cosmos has been calling the interchain for a long time. And so it's helpful to contextualize anything that's happening within this narrative because you realize, okay, it's not something completely brand new. It's just the dance continuing forward. And this is going to continue for as long as this industry exists. But where does that lead us? Well, it's just the beginning of this new infrastructure cycle that we're in. And if you look at the bridges right now, some of them don't look quite right. So the previous gentleman talked about the recent hacks that have happened in the space, and that's largely a result of this infrastructure being so new and people not knowing what SLAs, what guarantees they can get from them. The gentleman in the previous talk talked about subjectivity and giving more time. That is obviously one way to handle the limitations of the new infra. But bigger point is that in any cycle, in any app or infra cycle, at the beginning, we have a lack of understanding of what's exactly going on, and that maturity happens over time. And so, my point with this is to say that bridges have a lot of evolution ahead of them, and we'll see in 2, 3 years kind of really a more mature state of bridging. So the point of this presentation, if I can get to the next slide, well, looks like my clicker's dead. Give me a second. Let me go resolve this technical difficulty. Do y'all know how to get to the next slide? There we go. So as I mentioned, technology is very immature and doesn't work all the time. So that extends to the physical world as well. So yeah, I wanted to tell y'all a little bit about kind of what are some misconceptions that we have about bridging given that the infrastructure is in its infancy. And I think this is arguably the most important one that was demonstrated in the wormhole hack. Namely, when you're thinking about bridging tokens from one chain to another, you're not actually moving the token itself. The token remains escrowed on the sending chain, and then a synthetic asset, an IOU or representation, is minted on the destination. So bridges as a word indicates that our language is betraying us. A bridge is actually more akin to a synthetic asset exchange where you're saying, hey, I am locking these tokens up on one side, and then by some verification mechanism and relay, I will then be able to get that same asset on the other side via a representational form. The challenge about this is that what secures that escrowed asset? That's kind of, this harkens back to the Oracle problem where if you're on one chain, you cannot know what's happening on the other. The receiving chain cannot necessarily know what is happening on the sending. And so we rely on what's called a verification system to be able to know that that token has been locked, won't get double spent, and we can safely mint that representation on the other side. So it's important here to think about what the security model of that escrow is. And there's really, when we're talking about mint and burn bridges, being able to lock on one side, mint on another, then burn on that side and unlock, we care about what is the verifier, who is the verifier, and what is the trust model there. There's really two. There's native verification and external verification. Native verification is the ideal system. It's where we can just rely on the validator sets of the underlying chains to do that verification. So let's take an example. When you're sending from Ethereum to Polygon, the ideal state would be that the Ethereum miners and the Polygon validators are the only kind of actors whose verification that you need to count on. You don't need to introduce another set of actors. And how this usually works is you run light clients of either chain on the recipient chain. So in this case of Ethereum to Polygon, you would run an Ethereum light client on Polygon and a Polygon light client on Ethereum. And light clients, they rely on the assumption that the validators or the miners are honest. And when you're sending from chain A to chain B, you already have that assumption, so you're not including any more trust assumptions there. With external verification, you're relying on some external party, a multi-sig, a validator set, or somebody else to tell you that, yes, the tokens were locked on one side, now safely mint them on the other. But the downside about this is the miners and validators of the sending and receiving chain generally tend to be quite secure. You probably shouldn't be using those chains if they're not. But the external verifiers can have any level of security. If it's a multi-sig, a 3 out of 5 multisig, for example, you're relying on those 5 people being honest. And so we have to think about the verification mechanisms in almost a continuum. On one hand, you have IBC, which is a light client header relay based construction. Cosmos is entirely architected around this, where you only really need to trust the validators of the two Cosmos chains. On the other side, you have something like WBTC. Very cool. You have WBTC where you're trusting BitGo to receive your Bitcoin, and basically you're trusting them to then issue your Bitcoin as WBTC on Ethereum. If at any given point the custodian that holds your Bitcoin decides to do something else with it, you don't really have any recourse there. And so this gradient kind of shows you all the different variations that can exist in between. Wormhole and Layer 0 are both kind of external verifiers that rely on multisigs. Wormhole has 19 guardians where you need 13 out of the 19 to do the right thing, and Layer 0 uses a 2 of 2 multisig with a 2-phase commit. They require an oracle like Chainlink to give you the block header and then a relayer to basically send you the Merkle path that you can authenticate against the block header. But at the end of the day, it's still a multisig. Axelar takes it a little bit further and says we'll have n parties do the verification, but they will be dynamic and they will be selected based on a proof of stake consensus mechanism. The benefit of this is you don't have a static set you can corrupt. You can have 100 validators that if 67 of them are doing the honest thing, you're good to go. But now the downside is you've basically institutionalized bribery in another chain. You have told somebody if they buy all of the assets for the Axelar blockchain, they can then buy the validator set and corrupt the multisig. And so it's important when you're looking at these things to not just look at the number of people involved, it's how easy it is to corrupt them and find them and give them enough incentives to do the thing that goes against the user's wishes. Now, I'm working on Nomad. Nomad is a little bit interesting because, and a little bit closer to the native verification systems, because we don't use an M of N trust assumption. We have one updater whose job it is to verify and authenticate that cross-chain message, but we default to a one of N trust model because as long as there's one honest watcher that is maintaining liveness and observing the system, they can challenge fraud and be able to prove that on chain to prevent something bad from happening. And so this is more of an optimistic mechanism that relies on an external verifier but defaults to native verification. It is weaker than IBC because it doesn't give you full trustless guarantees, but it can be deployed in environments where IBC is not possible. And I know I went into a lot of technical detail here, but the big takeaway you should get from this is verification and the trust model of verifiers and verification systems always exists on a gradient. And if you are going to put a lot of money through these systems, don't just assume that once you've bridged over, your job is done. Your asset is always going to be escrowed, and you need to make sure that whoever is guarding that escrowed asset is somebody that you can either trust or challenge. So moving to the next myth, bridges need liquidity. When I'm talking to people about Nomad, they often ask, is there enough liquidity for me to not have too much slippage when I move my assets? It's an interesting question because I think it comes from the mental model of using something like a Uniswap. In an AMM, you often want to make sure that the liquidity pool that you're trading with has enough liquidity and depth so that when you trade one asset for another, you're not getting a really bad deal because that bonding curve slides to one side. The problem is, tying back into the previous myth, a bridge is not a liquidity pool. It is not an AMM. It's not a place where assets sit there waiting for you to swap and trade. A bridge is a way for you to lock an asset and get a synthetic on another side. That said, there are also liquidity networks like Connext that allow you to have that same kind of model of selling an asset and buying another one. And what these liquidity networks do is they use the synthetics that settlement layer bridges like Nomad generate in order to capitalize their liquidity pools. And the benefit of this is as a user, you do not have to interact directly with that locking and minting mechanism. You're just doing like a cross-chain swap. You're selling your Ether on Ethereum and you're buying it on Polygon. It feels like you've bridged, but somebody else created that liquidity beforehand and capitalized that liquidity network. The benefit of liquidity networks is they're often really fast, they're cheap, and they have a ton of liquidity, and you don't need to think about the security model. But they all depend on settlement layer bridges to work. So you can kind of think about this as two layers of one product stack. And I put Connext and Nomad here because we've partnered deeply with Connext in order to provide that solution on top of Nomad. In an ideal situation, we do not want retail users using Nomad all the time because we don't want them to have to think about the security model, lock a small amount of assets, and mint it on another side. We want them to use Connext because somebody else has already created those liquidity pools. And like if you all have heard of Celestia, Celestia has popularized this concept called modular blockchains. This idea that blockchains don't need to be monolithic. They don't need to do everything all together. One chain can handle consensus, another can handle execution, and by separating those concerns, each layer can be really good at the one thing that it specializes for. Similarly, we're pioneering the modular interoperability stack, where at the base layer, you have that settlement layer bridge that is secure and kind of allows you to have a lot of guarantees around the asset that you're minting, and Connext is that fast, zippy layer where you can get instant liquidity. And so I think this model will take a lot of root because each team can specialize on what it does best. Okay, third myth, bridges only work with tokens. In the first two myths, we've just been talking about asset bridging. We've been talking about you have a need to move your liquidity from one chain to another to ape into some yield farm that has 5,000% yield. Very fair. I want to do it too. But I think the bigger picture here is we're not just talking about moving assets, we're talking about chains being able to form an interconnected topology. So, in the example of Ethereum and Polygon, what about if you can lock up assets on Ethereum and then stake them on Polygon without moving them directly? Or even crazier, what if you issue a loan on Polygon? All of this is possible today and will become increasingly prevalent because each blockchain right now is a silo that kind of um, comes from how this industry developed. All these teams built these chains separately. But block space is the fundamental primitive that we're all kind of building for. And in the future, block space will be utilized regardless of where it is. And so, what we're moving towards is a world where bridges actually allow arbitrary messages to be sent between chains. And the real holy grail is a user in the future will not know what chain they're interacting with. They'll just want to interact with whatever, CryptoKitties or Sushi Swap or whatever the application is. They won't know what chain it's living on, and they'll be able to compose contract calls between chains without even knowing. In order for this to work, we need really, really secure message passing layers that handle that asynchrony without making developers think about it. So if block space is the primitive for computation, we need message passing channels that offer asynchrony as a primitive. And I don't know how many of y'all remember Yo. Yo was this app. It was one, I don't know when it was developed, but it basically was an app that raised like $2 million and only allowed you to say yo to your friends. I envision a future where blockchains can say GM to each other, and that's all that app does. So and finally, I wanted to, this is the, if there's one thing you take away, I want it to be this, which is that the last myth is that bridges are new, that we're in this new, shiny, multi chain future. This isn't new, it's just sharding. And it's just an evolution of what happened in 2017. Because at the end of the day, what people want is to be able to use censorship resistant machines where they can run computation. And what that requires is scalability. If this technology is going to reach world scale, we need to make it cheap, easy to use, and accessible for everybody. And the way we get there is sharding. It's evident because the previous like infrastructure cycle, as I mentioned, was around deploying all these L1s that would become Ethereum killers. They would become a world computer that could handle the load for everybody that wanted to interact with them. Turns out no one project was able to achieve that, but a lot of different L1s emerged, built by great teams that satisfied different users' needs and almost are built for app specific use cases. But we need a way for them to connect so that they provide this composite block space for everybody to interact. And so at the end of the day, interoperability is scalability. It's a way to say instead of making one machine really beefy and scaling up, we will have lots of machines that cater to different users' needs and we'll connect them all using transport layers. If this sounds familiar, it's because this is what the internet is. The internet is a lot of machines connected using common goods, public goods, transportation layers to facilitate seamless communication of information between them. We're just doing that same thing, but adding value. And so those are the myths. I hope I've kind of shed a little bit more light on bridging. You can find more information about Nomad as well as myself here, but would love to hear any questions or any thoughts from y'all. Yes, sir. Exactly. And so I'll repeat the question. The question was, do we envision a future where there are a lot more layer ones where if I'm building an application, I can spin up a layer one and then have it seamlessly connect to everything else? The answer is absolutely 100% yes. And Cosmos was the first ecosystem to see this. And that's why they built the Cosmos SDK, which allowed anybody to deploy a chain for whatever app they were building and automatically get IBC and connect to all the other Cosmos chains. The downside of Cosmos, though, is that it doesn't make it easy to connect to Ethereum and other EVM chains. What we're doing with Nomad is trying to solve exactly that, where regardless of where the chain emerged, whether it be the Cosmos, Polkadot, or Ethereum ecosystem, that seamless communication is available to any chain developer, regardless of where they start off. But I think the even crazier future we're getting into is commoditizing security, right? Like the security underlying the chain. I've been learning more about this project called Layer Labs that is building taking the ETH2 validator set and exposing their bond and security for any just-in-time application use case. And so they can tap into the validators underlying ETH2 and plug in their application and basically make blocks a little bit bigger and tap into that compute because it already exists. And so I think for application developers, it's the opportunity space is just exploding. You can either deploy your app on an existing chain, you can spin up your own chain and have it communicate to other chains that you want to talk to, or you can even just get block space on demand and talk to the validator sets directly. Cool. Gentleman behind you. Yes. Yeah, that is a great question. And I didn't touch upon this earlier, but what we're doing with Nomad is we're deploying the message passing layer as a kind of public good across many different chains, and then allowing application developers to build what we call ZApps or cross chain apps. And so a token bridge is just one example of a ZApp that you can build on top of the message passing layer. And so think about this as like a TCP IP that you can plug into and is deployed everywhere, and if you want to build some custom business logic for an app that you care about, but have it span two chains, you can do so using the Nomad SDK. That's like exactly what we're driving towards. So yep. So in order to just have the verifiers be the validators of the two chains, what you're doing with the light client is you're deploying a smart contract on Polygon that runs an Ethereum light client. So anytime I perform an action on Ethereum, I can prove that trustlessly against that light client contract on Polygon. So say what I'm trying to do is send 100 USDC from Ethereum to Polygon. I lock up that 100 USDC on Ethereum, and now Polygon needs to know, did I honestly perform that action and should I mint 100 USDC synthetic on Polygon? If I didn't actually do that, now we've broken the supply peg. But in order for Polygon to know that that happened, the most trust minimized way is for it to have an Ethereum light client running the entire consensus process of Ethereum on it. Then you can verify that trustlessly against the Ethereum state root and vice versa. Cool. Well, thank you guys. It's been fun. See ya.